Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about dynamic characteristics. So whenever you have a measuring system, so we have two characteristics. One will be static characteristics and another will be dynamic characteristics. So previous class we have seen the static characteristics. Now we are going to discuss about dynamic characteristics. So dynamic characteristics describes the measuring system, the input-output behavior during the transient, that is a changing in the input. So unlike static characteristic, which applies the constant or slowly changing input. So in static characteristics, the input is not changing; they will be stable, and then we are check the outputs. In dynamic characteristics, not like that. It check this input-output behavior during a changing time. That is a transient time. So good dynamic characteristics are essential for an accurate reproduction in time varying waveforms, and it is crucial for whenever you use the sensors is a part of control system to avoid the instability. So because whenever you are using these sensors in the crucial part, the sensor results is most important. There, if it inputs to output relation is not proportional immediately, or for example output changes in slow varying, what happens? It creates an unstable systems. Dynamic characteristics are affected in energy storing or releasing elements like masses, springs, capacitors and inductors. A time delay from a mechanical fluid displacement or even for a measured object that infect the media. So whenever we know that capacitor, whenever change in instant voltage, it won't allow because it's whenever from high to low, capacitor start discharging and maintain the previous outputs. Similarly, whenever changing from a low to high, it won't change the output from low to high immediately. Instead of whenever it changes like that, it charges the capacitor. After that only it gives for a full output. So instant change of voltage will be not be allowed in capacitor. Similarly, instant change of current is not allowed in inductors. So in electronics terms, we can say this capacitor inductor. Similarly, mechanical we can say this masses and springs. And important dynamic characteristic of linear or non-linear system, frequency response and time constant, response time, rise time and settle time. We can see each one. So first is a linear or non-linear system. A linear system responds to the multiple simultaneous input is the sum of its response to each individual inputs. The system is meeting this constraint is called, if it is a linear system. If it is not meeting that constraint, then it is called as non-linear system. See, we are giving some inputs to the system. So we are saying is multiple simultaneous inputs. So if you are giving that multiple simultaneous inputs and combining the results means that it will be same as the actual input is placed for. Linear system have a constant dynamic characteristic regardless of input amplitude, and the output amplitude is directly proportional to the input. So next will be frequency response. The frequency describes how the linear system output amplitude and phase shift varying across the relevant frequency range for a unit amplitude sinusoidal inputs. It is typically defined only for a linear systems. So because a linear system input can be represented as a sum of sinusoidal, and that frequency response completely characterizes in the system output at the inputs. A system describes the constant coefficient first order differential equation, and it is called as first order system. And then the time constant things. The time constant, it is a measured how quickly the first order system responds to the step changes. So normally we take from an output reaches its to 63.2% of its final value. For example, if the final value is 5 voltage means, so 63% of 5 voltage reaching time will be considered as a time constants. Response time, the time taken for the system output to reach the specified percentage. So for example, we are giving some inputs, it takes some time to reach the final value means that is the response time. So we consider as an 90 to 90% of its final value after the input change. So the time taken after input changes to the output reaches to its 90 to 95%. Then it is called as response time. Next will be rise time. So the meaning it have this rising time. So the time it takes the system output rise between a two specified value from a 10% to 90% of its final output for that input. So then this is called as a rise time. And next one will be a settle time. This is the time taken for the system output to stabilize with the specified percentage. So plus or minus 2% or plus or minus 5% we can check for a final values. So settle time means the time required to settle the output with a steady value. For example, output is high means it may go for a high and it may have some oscillations. So if it settles to the final value with a variation plus or minus 2% or plus or minus 5%, then that will time taken will be called as settle time. Thank you.